A quadratic irrational can be represented by a periodic, infinite, simple, continued fraction. Let y equals to the quadratic irrational, then we can write y0 equals to y and a0 equals to greatest integer of y0, then y1 equals to y0 minus a0 and a1 equals to y1 dot y n plus 1 equals to 1 by yn minus an, then an equals to greatest integer of yn, n is greater than equals to n0. Here all the y's are quadratic irrational. Then let y equals to a0, a1, a2, triple dot an minus 1, comma yn. Then we have to show for some value n that y is reduced quadratic irrational. For that we have to show this property yn is greater than and minus 1 is less than yn bar less than equal to 0 for some n. By construction, yn is greater than equals to 1 for n greater than equals to 1. Let take n equals to 1, y1 equals to 1 by y0 minus a0 and a0 equals to y0. y1 greater than equals to 1. Since we know that 1 is greater than y0 minus a0 and greater than equals to 0 for n greater than equals to 0. Now a0 semicolon a1 a2 a minus 1 y. This formula is from Cn by Qn. This is from formula y equals to a0, a1, a2, an minus 1, yn equals to yn, en minus 1 plus p n minus 2, qn minus 1 plus qn minus 2. We just take the negation conjugate of we just the conjugate or bar, then we just multiply here. This become yn bar and then yn qn equals to yn en minus 1 plus pn minus 2. Then we just imply that yn bar qn minus 1 minus yn bar pn minus 1 equals minus yn qn minus 2 plus pn minus 2. Then yn equals to minus yn qn minus 2 plus pn minus 2 y bar qn minus 1 minus pn minus qn minus 2 from this term, and this become yn bar minus pn minus 2 qn minus and qn minus 2 qn minus 2. Then take this from this side and this term from this side, then become this, and we just put this negative here. Then this as n to infinity, this term goes to 1. Then put 1 qn minus 1 divided by qn minus 2 yn minus 1 equals to 0, tends to 0. Then for epsilon greater than 0, there exists an integer in 0, so that minus q minus 1 divided by qn minus 2 yn bar minus 1 less than 1 for all n greater than equals to qn minus 2 yn bar minus 1 less than equal to 1. We just add this term, then they become 0 and this is 2. Then this like the other term implied is greater than equal to 0. This term is negative to be negative if it's greater than 0. If minus qn minus 1 by qn minus 2 is negative, then yn is also negative. N bar is less than 0 for all n greater than equals to n0. Since q minus 1 divided by n minus 2 greater than equal to 0, by definition yn n plus equals to 1 by yn minus y minus an, all n greater than equals to 0, all n greater than equals to n0. Since an greater than equals to all n greater than equals to minus e, then it's negative is less than equal to minus 1. Then we just subtract yn an, then this term is we get, then 1 by yn bar minus an greater than equals to minus 1 for all n greater than equals to n0, that is nothing but this term. So we put the value by yn minus an as yn bar plus 1 all n greater than equals to n0. If r is greater than minus 1, then yn is greater than equals to 1. In particular, if n equals to ng plus, then yn less than equal to 0, imply y equal to a0, 7 a2 n0 comma y n0 plus 1. Since y n0 plus 1 is a reduced quadratic irrational, it has a periodic, then it has a purely periodic infinite simple continuation. Let y at this term b0, b1, b2, bn, then we put the y as equal to a01, a2, 0 v1 v2 vn bar, which is a periodic infinite simple quantum fraction. This is our theorem. You have any question? Those you want, please